Please, oh, okay. I say, okay, continue. All right, hey, very happy to have with us today a gentleman named Mike Simmons that's going to talk about electrification and energy efficiency. Mike's been involved in building performance for 10 years, from running over 1,000 mass save energy audits to training over 100 energy auditors. He's learned how homes work and knows how to fix them. He was part of the launch team of two energy efficiency companies, the first being a home performance contractor, HPC, that has since grown to be the second largest in Massachusetts. His current employer, Abode Energy Management, has him doing what he does best, developing, providing comprehensive training related to energy efficiency, whether serving as a BPI proctor mentor, teaching emerging professionals building science, or making heat pump design understandable. Mike tries to put the fun in the fundamentals of energy. And I have a little story I should share about, because it was my idea to have Mike do one of our climate conversations. And I met him through Homeworks, who I worked with to have my home insulated this winter, to have the insulation blown in to the walls. And a funny thing happened. My return ducts for my gas heating system got filled up with cellulose. And it turned out that the channels, there was no real duct in the channel in the wall, so the cellulose just poured in. And as I was talking to Homeworks, I also said that I was kind of concerned about the amount of electricity my heat pumps seemed to be using. And of course, though, this was before I had got the house better, more insulated. So hopefully things would get better later. But anyways, they suggested I talk to an expert from Abode Energy Management, and that was Mike. And in talking to him, I found he was so good at explaining things and putting some of my anxieties and doubts and concerns to rest. And that it just got me thinking, boy, it'd be really good to have you come and talk to our group. So without any further, here he is, and let's hear what he has to say.
Well, thanks for the introduction, Tom, and just hope everyone can hear me fine. Yeah, I'm going to just, Tom already kind of covered the majority of what my professional background is. On a personal level, a little bit about me is we just bought our home this past August. It's a 100-year-old home out in Leominster. And having spent my professional career in energy efficiency, I've been tackling pretty much energy efficiency projects nonstop since buying it. Just this past week, we finally got our Ductless system installed, and I'm now the proud owner of 6 indoor units, 3 outdoor units. Next on the list is we are going to be adopting PV. And I do think from a lot of my own personal experience that will inform some of the discussion that we'll have today. And just real quick, so one of my job duties right now is I serve for the city of Cambridge. I'm their clean heating technical advisor, and I'm offering kind of homeowner consultations for trying to adopt this and work with contractors and making sure that the system makes sense for their home. My company that I work for, we do that type of service for a lot of municipal light plants. So probably your closest neighbor would be Reading, has their own municipal light plan, and we oversee their heat pump program and their rebate processing, things like that. But the big thing that my company does is we oversee all the home performance contractors in the Mass Save program on behalf of National Grid. So we're working with all the independent contractors, making sure that the energy audits go well as the weatherization work. So if you do get work done in the Mass Save program in Chelmsford, there's a good chance that we would be overseeing the project. So if anything comes up in that, you're more than welcome to reach out, and I'm happy to make sure that things get ironed out and go smoothly. So I just structured this presentation kind of as like, these are all the questions that I hear about, heat pumps, and this is kind of how I think it would be good for people to think about the correct answer, at least one of them. So here we go. So why are people so excited about air source heat pumps? And I think that Tom kind of hit on this already with his like existing situation with his like gas furnace and his distribution. So let's just say that you're bringing in like 1 gallon of oil into the house. When you go and you like combust that 1 gallon of oil, at the very like best designed oil system, you're going to be losing at least 10% up the chimney. You're going to be losing another 3% into the as it cycles on and off, on and off. There's inefficiency with just say taking a fossil fuel and setting it on fire and sending it out of your home from the luxury of your basement. With a heat pump, and let me talk about something in between. So let's just say instead of doing that, instead of having those losses going up the chimney or having a system that's cycling on and off, let's just say you had an electric space heater. You plug in an electric space heater, you put in 1 unit of energy, you get out 1 unit of heat. So that system hypothetically is like 100% efficient. With a heat pump, whether it's like an air source heat pump, like a ductless mini split, which we'll see a lot more examples of, or a geothermal system, you're putting in 1 unit of electricity and you're using that unit of electricity to power the refrigeration cycle, and it's able to move typically about 3 units of heat into the house. So what this actually ends up looking like, if we were to look at, the proportional amount of like BTUs, British thermal units, so that's like units of heat per dollar that you put in, this is exactly kind of like what it looks like in the Massachusetts landscape. So let's say that you put in $1 worth of electricity, you're just getting that like little of electric resistance, you're just getting that little unit of heat. But say you're putting in $1 of home heating oil, the unit of energy that you're getting from that dollar is quite large, or a lot larger than electric resistance, but you see that there's a good chunk taken off of it. And that's all of the inefficiencies that come with burning home heating oil. Natural gas, you see, that you're getting actually more BTUs per the dollar today. These things always fluctuate, but with the natural gas system, because it burns a lot cleaner, there's a lot less byproducts, you can actually get a much more efficient system. With air source heat pumps right now in today's fuel prices go, what's neat about them is you're putting in the like $1 worth of energy, but that's a lot bigger than electric resistance. And what's exciting about that is it makes it cost competitive compared to fossil fuels. Now, let's just say that we took this air source heat pump and let's say that we moved it into a place where electricity is wildly cheaper, let's say like Pennsylvania or West Virginia. That air source heat pump like circle would be a lot bigger than natural gas. So the only thing that is holding it kind of down when we are looking at it visually is just in Massachusetts right now, electric prices are relatively expensive compared to gas prices. But as far as the air source heat pump with the efficiency of the unit, it does make it kind of cost comparable, but it's also a lot cheaper, or it is cheaper than home heating oil right now. So I don't think a lot of people are so excited about air source heat pumps just because it's like they're cost competitive to fossil fuel. I think a lot of people are interested in air source heat pumps because they're a lot cleaner than fossil fuels. So right now, today, if you took an air source heat pump and you ran it year round in our region and the system is well designed, it would have about 30% less emissions than natural gas. It'd have close to it would be 50% less emissions than home heating oil. And why air source heat pumps are likely part of the goal for electrification and decarbonization is because every single year our grid has been getting cleaner. So first it was getting cleaner by getting the old coal-fired power plants taken offline and replaced with natural gas-fired power plants. But now with offshore wind in Martha's Vineyard becoming a reality, likely getting hydropower down from Quebec likely being a reality, in Massachusetts, we do have a pathway to be getting this grid nearly powered by 100% renewables. And we'll revisit renewables in just a little bit as well. So it's really the only technology. You put in a 97% efficient gas furnace, it's always going to be producing the same amount of emissions between here and 2050. But if you're putting in an air source heat pump today, every single year, that system is going to be producing less emissions. Okay. This question comes up a whole lot. How does a heat pump work? And I think it's helpful to start with saying that everyone, I don't know why it's hopping ahead, that everyone currently has a heat pump inside of their house, whether they know it or not. So a heat pump works the exact same way a refrigerator works. It takes the heat that's inside of the box and it moves it outside of the box, and it uses electricity to do that. A window AC works the same way. It takes the heat from inside of the box, your house or your apartment, and it puts it outside the box. With a heat pump, in heating mode, what it does is it just takes the heat from the outside air. So let's just say that it's 30 degrees. 30 degrees has a lot more energy in it than 5-degree outside air does. So it just takes that 30-degree air or that 5-degree air and it passes it over an extremely cold coil. That extremely cold coil ends up absorbing the energy because hot goes to cold. It then moves that refrigerant inside to a compressor. And as you increase pressure, you increase temperature. So as they compress that extremely cold, let's say now 5-degree refrigerant, it instantly becomes 85 degrees. And a fan inside of the home blows over that. And now your house is going to be warm in the winter, or it can work in reverse as cool in the summer. So as far as like the technicalities of following the refrigeration process and the indoor and outdoor unit splitting functions, it doesn't like that. I think the most elegant way that I ever heard this explained is like, how does a heat pump work? And someone said it works really well. So you don't really need to worry about the technical details, but we will talk about the specific type of details that you need to worry about, which is like how to actually select an air source heat pump. And this is probably the topic I think where there's the most confusion on right now, and that's, can a heat pump replace my existing heating system? And it's a tricky question with not a simple answer. So over here, both of these things are automobiles, but they serve wildly different functions, okay? So for some people, they need a pickup truck for work. There's no question that like you need this much horsepower to get by. For other people, they don't need, they don't need all of that horsepower, and they can get something smaller, sleeker, more efficient to run, okay? So just like with different heating systems, there are the right heating systems for different types of homes. And I think one of the messaging over here is not that you need to get one or you need to get other. And there are plenty of examples where it may actually make a ton of sense where you would need to get both. But one thing that isn't kind of outlined over here is that fundamentally with a heating system, all it is a plant, okay? It's just generating BTUs, and your house needs BTUs, or British thermal units, to replace all of the energy that your house is losing. So say if we look over here with the furnace, which is over on the left-hand side, that may be a 60,000 BTU furnace. Over here, that may be a 100,000 BTU steam boiler. There could be a 60,000 BTU gas hydronic boiler, and that may be a 24,000 BTU heat pump. All of these systems have different BTUs, and there's nothing that's right about them or wrong about them. The question really is this the right piece of equipment for the home? So let's just start, for example, that if we're looking over at that we're looking over at this furnace right over here. I said it's like 60,000 BTUs. If you want to get a heat pump to replace this gas furnace, just get two 30,000 BTU heat pumps. It's a one-for-one swap. Now the question that I have is going back to Tom's example that had his ductwork completely connected to his, wall cavities, is did his house actually need a 60,000 BTU furnace if you remove the ductwork? Because the distribution could have accounted for 20,000 BTUs of losses, and maybe he only actually needed a 40,000 BTU system if all of the heat that was generated from it actually made it into the home and not out the walls or out the floors or up chases and out through the roof. So this is really like one of the big things that someone needs to think about when upgrading from a forced hot air system. Going from a steam system, I have steam in the background and I have a heat pump over here, and I love them both differently. But with a steam system, anytime that you're trying to get like 1 BTU from this boiler up to this radiator back here, I probably need to heat up somewhere between 5,000 and 10,000 pounds of steel and cast iron to the boiling point, to 212 degrees, before a drop of steam will start migrating up through the pipes and into that radiator. It's worked for 100 years, but there's so much energy that's just being used in distribution that even if this is like a 100,000 BTU boiler, the distribution loss is going with steam is factored in, like by the mechanical engineering standards of the day, is like 30%. So I really only need 70,000 BTUs. Say, because steam, you can never have a high efficiency steam system because you need so much gas going into it, you lose another 20%. So this steam system, just looking at it, knowing with switching over to air source heat pumps, I'd probably need like 60,000 BTUs of air source heat pumps. And you can kind of go on with this exercise no matter what type of a heating system that you have. But I do want to just put one of the takeaways, and we'll go talk about this again, is that cold climate air source heat pumps can maintain 100% of their capacity to the design temperature in Chelmsford. So you don't need to worry about like, can this heat pump do the same thing that my heating system can do? The answer is yes, it can produce plenty of BTUs at the design temperature. Is this true for Anchorage, Alaska? No, I wouldn't be doing this presentation in Anchorage, Alaska, saying that you can swap a steam boiler for an air source heat pump. So as we're just talking about this, I did mention, kind of allude to the next slide. Like, so there's the heating system, which is just producing energy, and it's the distribution system of getting the energy to where you want it to be. And this is the equivalent, the difference between like both the Tesla and the F-250 or whatever it was. Both of those are automobiles. They perform the exact same way. They're just a vehicle to get you to where you need to go. Where a heat pump is different from a traditional heating system is how that heat is distributed and whether or not it does make sense for your home or your property. So with steam systems, it's going through radiators, through forced hot air, it's going through ductwork, through hydronics, it's typically going through baseboards that are on a circuit. And the tricky thing about this is if you want to adopt air source heat pumps and you want to put a radiator, you want to put a mini split everywhere that there's currently a radiator, or everywhere that there's currently a floor register, two things are going to likely happen. One, the system's going to be oversized for your house. And the second thing is it's going to likely not be cost competitive versus just replacing the existing heating system. The project's likely going to like absolutely blow the budget unless it's a condo. So there does need to be some decisions that are made of how to kind of match the distribution system of a air source heat pump to something that's comfortable for your home. And we'll revisit this shortly, but just know that's really the big difference between a traditional system and a mini split. It's not its ability, or air source heat pump, it's not its ability to generate heat. The big question I think that anyone who's considering this is how it's going to be distributed throughout the home. So what's so good about heat pumps? I'd say that there's kind of a few reasons why people do like these heating systems versus, I think, more traditional mechanical equipment. One is they're super, super quiet. The indoor units, you typically, like, if they're on low, and they're usually on low if they're just keeping up with the load, you have to kind of like put your hand up next to them to even feel if they're on. With the outdoor units, there's no hard starts and stops like a traditional central AC. So there's like very little outdoor noise. You hardly know that they're actually running. For air conditioning, compared to the competition, I'd say that there's a few advantages. So they just mount, when you are looking at ductless, they are just mounted on the wall and the floor. So you're not losing, you're not losing your ability of your window being, operable. You're not losing the sight, the visibility, the security, the infiltration, like all of those things are eliminated. But one of the other things that's really gained is a traditional mini split has about double the efficiency that a window unit would have. So a window unit would have an ER rating, an energy efficiency ratio of like 10. Well, most multi-zone mini splits have a SEER rating of 20, so it's twice as efficient. So if you were to find that your August electric bill, you're spending $200 in cooling, if you were to adopt a mini split, it would likely be $100. With my own system, my multi-zone has a SEER of 20 and my single zone has a SEER of 30. So that, let's say, $200 electric bill with my most efficient system, it would be the equivalent of a $50 electric bill. So there is a nice drop in that. And I think the other reason why people really like mini splits as well is for the ability to zone. So if there is a room in your house that's hotter or colder than another room, you're able to kind of offset it. So classic New England Cape, everyone's finished attic is a lot hotter than the other sections of the home. So it becomes a really nice way to add cooling up there in an elegant way. And then there is always this idea that you could zone each and every room of the house, but I don't actually think that that's the best strategy, because this would likely lead to a oversized system that's not going to have the operating costs that people are expecting. All right, we're now going to go and just talk about what heat pumps look like. So there's a variety of different ones. So there's ones that mount just on the wall, there's ones that sit down on the floor, and then there's ones that could be just tucked up into the ceiling. So these are all the ductless varieties. So when we do say ductless mini split, the ductless is referring to the fact that there's no sheet metal distribution for the systems. Okay. There's another product category that's tied to the same outdoor units called the ducted mini split. And these could be used to either condition one room or two rooms or an entire floor, or you could use it the same way as a traditional gas furnace would, where you're using one system down in the basement or up in the attic, and then you have trunks of ductwork running to all of the different rooms. They both have their pros and cons, and we'll have some examples of that in just a little bit. But anytime that you do have an unfinished basement, these are actually a pretty good solution to not to have, so you're not looking at the units, you're not seeing the units, everything's kind of concealed underneath. And it does make sizing a little bit easier with kind of getting distribution to all the different corners of the house. Are we doing good so far with no questions? Tom,
There's only one question in the chat that we can hold. In
Okay.
fact, you might be getting to answering it
okay, perfect.
right now.
All right, can I get rid of my existing heating system? And the question I would say over here is maybe. I think that there's a deeper question of resiliency that needs to be kept in mind. So for equipment right now, there is this piece of equipment that Mitsubishi makes. This unit supplies 54,000 BTUs at 5 degrees Fahrenheit. This is what gets laboratory tested. This is exactly what this heating system does. For most homes in, say, Chelmsford, probably the average about BTU per square foot is about 20 BTUs per square foot, and your design temperature, I think, is 2 degrees. So if you just kind of do the math that the average house is like 2,000 square feet, I need 20 BTUs per square foot. This is more than enough. This is more than enough capacity. With this type of piece of equipment, you can have like 8 separate indoor units. So yeah, you can probably do it. There's nothing wrong with with just going and doing this. As far as the distribution goes, though, that I do think gets trickier, because then the question is, if you do have 8, you're really needing to buy, say, like 9 pieces of equipment. And in Massachusetts, I'd say that each individual unit costs like $3,000 to $5,000. When, say, tied on to that, you have 8 times 3, 24 plus this. It's like maybe that would cost $35,000 versus just, say, replacing your existing boiler, and it's like $10,000 or $14,000. So can you replace your existing heating system going all ductless with this piece of equipment? Yes, but I do think that not a lot of people are currently doing that.
Okay,
So
hold on, Mike. Let's pause for a second. We got 2 questions. One of them, Dave is asking what mini split means. I mean, so actually what is the term? Why do they call these things mini splits?
Yep. Yep, that one's easy. So let's just say that you were staying at the Chelmsford Motel. I don't know if that exists, but let's say you're staying at the Chelmsford Motel and there was a heater that was on the wall, okay? And you could flip a switch and it says cooling or heating, and then there's a dial from low to high. That type of a unit that would make a good deal of noise and probably leave the apartment somewhat cold and clammy in the summertime. With that type of a unit, that's called a packaged unit. So everything is packaged together. And let's say you go and walk into Home Depot and you look on the ceiling, there's going to be registers that are right in the ceiling of that type of a building. Sitting on top of that is a packaged unit. All of the components are put together, and they're a lot less efficient and they're a lot more noisy. So people typically prefer split units. So a central air conditioner is a split unit. There's the outdoor unit that sits outside. There's the indoor unit that's in the basement or up in the attic. So when we say ductless mini split, the split is really the separation of the indoor and the outdoor unit, which traditionally on a cooling system would be the evaporator on the inside and the compressor outside, but with a heat pump, they work both ways. The mini is referring to its traditional capacity. So instead of like most American style systems, there would be like 3 tons or 4 tons. Well, traditionally a heat pump was a lot smaller. It was providing 6, 9, or 12,000 BTUs. And just, I always forget to say this, but you need 12,000 BTUs per ton. So the mini was originally related to its capacity. And then the ductless was just referring to that there's no duct work on the traditional units. But now ductless mini splits, ducted mini splits, ducted multi-splits, all of those are terms that kind of encompass these sorts of manufacturers and products.
Okay. And the second question kind of goes with what your previous slide. You're talking about whether you can replace your whole heating system. And this question from Chris Roger is asking, like when should you, in a sense, and what the environmental impact of taking out your furnace? Should you wait till the furnace dies first?
Yeah, I would say that it's a case by case basis. I would like to see people install these systems to meet their home's heating load while their existing system is still up and running. Because I think that what we learned from Texas, and I think what we've learned with like the Colonial Pipeline, is that having redundancy in a system certainly doesn't hurt. And I think that it would be nice to get through a winter or 2 winters and ensure that the heat pump is able to do exactly what you want it to do, that you're not going to have any concerns with pipes freezing or cold spouses, or any major grievances. So I do think that the right approach with adopting these is I would always be trying to not choose one or the other, but I'd say, I would say, that your heating system's not going to last forever. Adopt heat pumps now, size it for the design temperature, ensure that it's doing what you want it to do. And that way you will have confidence that it's safe to pull out the old heating system versus kind of going all in and maybe oversizing the system because you weren't sure, because you need backup. So I think preemptive is a better approach.
Okay.
But,
All right.
let me just talk real quickly about this, because I think this is a really big, this is kind of a big thing to be pointing out. So I said that the average amount of BTUs that you need is about 20 BTUs per square foot. Average home in Chelmsford is about 2,000 BTUs. So with sizing a heating system to meet the design load, which for you guys is about 2 degrees, you would need about a 40,000 BTU heating system. So let's just say that you are interested in putting in 3 heads. Most of the systems that are going to say cover 3 heads are going to be somewhere around 24 to 30,000 BTUs. So what does that mean? So if you just put in a 30,000 BTU heating system and your heat load is 40,000 BTUs, whether you intended to or not, all that you did is you're going to be displacing a good portion of your heat. Now, let's say between 0 and 70 is the middle of that's 35. Okay, so if you at 35 degrees, you would need 20,000 BTUs of heat. Okay, so just knowing kind of what the capacity is of what you put in, it can kind of tell you how far down you can go. So even though that let's just say you put in the 30,000 BTU heating system, you cannot replace your existing heating system and feel good all winter knowing that that's what you did. With a 30,000 BTU heating system, you're still probably able to run that thing as the sole way to heat your home down to 17 degrees. And there's nothing wrong with doing that and only using your existing heating system for the coldest of cold days. At the same time, there's nothing wrong with investing and getting an additional 12,000 BTUs to make up the 10,000 that's missing. And now you have a system that size, let's say 2 systems, you have a 12,000 BTU system and a 30,000 BTU system, and you're able to then drop your existing system down in the basement. So there's nothing wrong with having a strategy where I'm going to start with a 12,000 BTU today, and then I'm going to put in a 30,000 BTU system a few years from now, or vice versa. I just want to get AC in all of the bedrooms now, putting in a 30,000 BTU system. I'm going to just run those systems, hope that they migrate their energy or their heat to the inside. And then, further down the line, when budgets allow, add an additional 12,000 BTU system, which may cost $5,000 versus replacing your existing system down in your basement, which could be $8,000 or $14,000. So there's there's nothing wrong with a strategy if you should just replace everything at once, or you should just try displacing some of the fossil fuels today. I would just say that you should have some sort of a strategy with if you are interested in this and your budget isn't allowing you to do everything at once, where are things going today and where are things going next year or 2 years from now? Because you don't want to be moving heads around and things like that. It'd get really expensive. So one of the things that I think would be really important for all of you to realize as you're looking at different manufacturers, all of their outdoor equipment. So it has how many BTUs and how many zones it supports. So oftentimes when you are just thinking about the system and you are thinking, oh, I want one in each and every one of the bedrooms, and I want one in the dining room, the living room, and the kitchen, and say that you're all right, well, now we're up to 6 heads. With just looking at these possible combinations, to have 6 heads, I'll either need 3 18,000 BTU systems, or 4 or one 36, and then another 18. And going back to most homes probably only need about 40,000 BTUs. The capacity that you would be buying with sizing it just based off of a head in each and every room, it's not going to match up well. So I do think that having some design decisions of where do we want to put these would be really helpful as you are starting to get quotes. Because as you do meet with HVAC contractors, they are more than happy to sell you as much equipment as they can, especially if you're leading the conversation with oh, I want one in here and one in here and one in here and one in here. They're okay. So just be aware that putting a head in each and every bedroom is likely going to result in oversizing. The consequence of oversizing is likely going over the budget. The other thing is the operating cost of these would not be what you expect it to be, as well as the amount of CO2 equivalent emissions that they are going to be putting out. Because when these systems are oversized, they're going to lose their ability to modulate, and they're going to be turning on and off, on and off, on and off. And every time it cycles on and off, it ends up using more energy and more electricity to run the system than the manufacturer ever intended for them to use, as well as it's outside of all of the conditions that they get tested at and what they're supposed to be doing. So oversizing is really good to avoid. It doesn't typically affect the comfort of the systems, but it can have, if it's horribly oversized, it can affect the ability to control humidity. So are they affordable? And it depends. There's nothing wrong with trying to use a system the exact same way that you would a wood stove or a pellet stove. If you're heating your home 100% of the winter through a pellet stove, and you don't mind that the bedrooms are a bit colder, that the living room is a bit hotter or significantly hotter, you can run a mini split the exact same way. It would be the cheapest way to switch off of fossil fuels and all electric. You just put in one very large unit likely, and have that sized to, and have that sized in a way to making sure that it matches the heat load of your home. The cost of doing this right now, I'd say market rate in Massachusetts is between $4,000 to $6,000. Alternatively, you could try and attempt to do what I just recommended not doing, and that's likely putting a mini split unit in each and every bedroom. And the consequences of doing that is there's going to be less efficiency of it. It'll be cycling a lot more. And now the budget for heating that house, instead of it, $5,000, now it's $15,000 or $20,000, or heating that floor. And if we do just size this up to say 2 floors, you know, now you're talking at $30,000 to $40,000 with this type of approach. As someone who's been doing energy efficiency for the last 10 years, this ideally is what I would like to see. This is how to kind of do everything just right, where it's like no compromises on comfort and no compromises on performance. So for the large open area, you put in 1 mini split. For the 2 bedrooms, you come in down through the basement, you put in like a medium static ducted unit, and then you have a supply register going into the bedroom. The other bedroom, you could probably run one over into the bathroom over there. And the cost of doing that is probably between $15,000 and $22,000. Once again, say if this is a 2-story house, it could only go up from there, okay? This is so let's just say if budget is not an issue, trying to get the right performance, this is a really good approach. This is the approach that I took with my home, and I think this is what makes a lot of sense for a lot of people. So over here, we just have 2 heads. We're providing heat on one side of the house and we're providing heat on the other. We're hoping for the best that you turn this fan on high, and that's helping to blow space into here. You have a unit in your master bedroom, so you're really happy all day and night. And this unit's just trying to pick up a lot of the load. This is certainly going to be picking up some other load from over in here. But this is kind of what a lot of people are trying to do when they're trying to avoid the cost of duct work, which is quite expensive in Massachusetts because everyone needs, because the contractors need a license to do that. So this I think is like, you know, to get the system so it's modulating as much of the year, not costing a fortune, can become competitive versus a traditional heating system, or slightly less as well. And we'll talk a little bit more about examples with how much these, and all of those prices that I just showed, all of that is retail. That's all before rebates and incentives. And I know with Chelmsford, there's a lot of home heating oil still out there. For home heating oil, there's like in Mass Save, there's a $1,250 rebate per ton. The Mass Clean Energy Center, they're wrapping up a program that I'm getting for my own home, where my Ductless project, I'm getting a $7,500 rebate from them for going all ductless. With the DOER, they have an alternative energy certificates for homes that are adopting electrification. And that's going to be a few hundred to a few $1,000s, depending on the market rate of these certificates. With Clear Result, they're the ones who administer the Mass Save programs, but they offer a 0% interest loan with a 7-year term for financing 100% of the cost of these projects. And ICF, they manage the Mass Save new construction and renovations program. And if you're putting an addition onto the home, it depends on how far you go with the envelope, but the heating system, the improvement of a mini split compared to a traditional non-Energy Star heat pump, the difference of that gets claimed in the savings as well. And so you get a nice rebate from them from that technology. This is a hot button subject. And I think I kind of already talked about it, but I just want to hammer this home. Can a heat pump really be used in our climate? And over here is just information from a few different manufacturers, and I could have pulled it from more. So I got Mitsubishi, I got Fujitsu, I got Bosch over here. All of those manufacturers, they sell traditional air source heat pumps and they sell traditional mini splits, but they also have a brand that would be called a cold climate air source heat pump with no capacity drop off. And what that means is if it's 47 degrees outside or if it's 5 degrees outside, that unit can still put out the same exact amount of energy. Okay, so let's see what that actually looks like as an example. So over here, we have the houses, we have the house over in blue right over here. And this house is also, the heat load of this house is right about 40,000 BTU. So if we go and we look at the heat load of the house, and I pulled this from Cambridge, so it stops at 12 degrees and not 2 degrees, because you guys have different heating design temperatures. So at 70 degrees, this house needs 0 BTUs. At 12 degrees, this house needs about 36,000 BTUs. Now, if we were to look at this heat pump, which is made by Bosch, this is one of their models, at say 50 degrees, this heat pump can put out 36,000 BTUs, how much this house needs. But as the temperature does drop, the capacity of the heat pump drops. So because that is true, this heat pump would no longer be able to keep the house to 70 degrees, somewhere between 20 and 25 degrees. And there's nothing right or wrong about this model. It doesn't mean that this model can't be a great AC system and a great way to not run fossil fuels down to, down to 22 degrees. Like, that's still good. You just need to have an answer for what happens before that. And going back to, I think, the previous example, if we do bring this all the way down to like, 2 degrees-ish where you need it to be, the difference between the two is just like 12,000 BTUs. So maybe it's like you put this heat pump on the second floor, cover all the bedrooms, and on the first floor, you just use one of those, Mitsubishi or Fujitsu wall hung units that's 12,000 BTUs. And then you got the whole heat load covered. So there's like nothing wrong with this piece of equipment. You just need a strategy for adopting it. Here's another piece of equipment, and this one's from Fujitsu, and this would be an example of a heat pump without a capacity drop-off, or with very little of a capacity drop-off. This heat pump is listed as a 36,000 BTU unit. It actually supplies more than 36,000 BTUs of heating at 50 degrees all the way down to 15 degrees. At 15 degrees, it does drop its capacity down to that 36,000 BTUs. But at this stage, this heat pump has more capacity than the home will ever need based off of its design temperature. That doesn't mean that there's polar vortexes are not real, or a -5 overnight windy day. That does happen or can happen. And yes, this heat pump will have problems keeping the house to 70 degrees during that time. But nobody, whether it's a fossil fuel heating system, whether oil, gas, propane, whether the distribution's forced hot air, steam, forced hot water, no one's supposed to ever design a heating system for those scenarios. They're supposed to design it for the design load. And what ends up happening, it's not like the heating system just gives up or explodes or the house becomes suddenly freezing. Instead of being 70 degrees, all right, it's 69 degrees or 68 degrees or 66 degrees. It's not a big deal. There could be some, comfort issues, but usually these extreme weather events, they happen overnight when we're covered in covers. So I wouldn't be too concerned about that. My big concern with people abandoning their existing heating system is really related to heavy snow. So it's like, like the blizzard of 78 happened, what happened in 2014? Yeah, 2014. And we were living in Boston, and, the snowbanks were, pretty much up to the top of, like, they were like a story high on most sidewalks. Like, yes, those extreme weather events do happen. And I do worry about, people, I can't say universally that everyone's going to have the ability to go out and shovel this thing out, if we get 2.5 feet of snow overnight. That's my big concern with people switching over from fossil fuels over to air source heat pumps, is just how are we going to keep that outdoor unit clear? There's best practices where that outdoor unit's on a 1.5 foot stand, or you can even mount it up higher on with mounting it to the side of the house. But that's really the only reason that I'd say, like, you know, move cautiously, because I think that you do need a strategy for making sure that those things are able to do what they need to do. So just to try and help everyone understand. Oh, go ahead, Tom.
Yeah, Mike. One thing, even when you have the hyper heat type that can work to down to 0 degrees or below, and you said that they could, the capacity is still enough, but doesn't the efficiency decrease and therefore the cost increase the colder it's getting?
Yep. Yeah, no, you're 100% right, and we can revisit the submittal that I showed earlier at NEAP. But so there's definitely ways to kind of hack these things together, and that's not the hack as in good hacker, not hack as in hacking things together as in bad. There is a way to kind of integrate how you think about these systems with your traditional fossil fuel equipment to both maximize savings and also reduce CO2 emissions. So we can explore that a little bit later on, but I think that we would best do it with looking at the actual submittal, because then we can see exactly what the coefficient of performance of these systems are at different temperatures. If you were attending a, let's say like and hopefully this doesn't seem like a hooray heat pumps type of session. Like, I hope that this really feels like I'm telling you, like, all of the considerations you should be thinking of as homeowners if adopting this makes sense. But if you were going to, let's say, like a go heat pumps, hooray heat pumps type of session, you would be hearing me talking about how these systems are, you know, have a coefficient of performance of like nearly, you know, 3.2 and things around that nature. Like, I try to be very conservative while I'm talking about them, so we don't get any calls that say, why is my gas bill was $400? Why is my electric bill $600 or $800? You know, so, but that annually, if you do annualize kind of all of the different coefficients of performance at all of the different temperature ranges, annually it should be about a 2.7 or 2.8 for a well-designed system. And when I'm talking about those numbers, that's where you have that 30 to 40% less emissions over the course of the year with just running the heat pump versus natural gas. But there is certainly ways that you can do it where you turn the heat pump off at freezing, and now it's always just running at a COP of 4, you know, a COP of 4, and now it's 50% better than natural gas because the heat pump is being, you know, only used at kind of like the most opportune ways. But yeah, it's all very tricky, and fuel prices fluctuate, CO2, but like this, and the CO2 emissions are getting cleaner. So there's nothing wrong with having a strategy for doing them both, but it does get complicated. It's really a case-by-case basis. Sorry, hopefully that partially answered it, but it'll be helpful if we go back and look at the submittals. So I just want to go and highlight, I'm just making a note here, just kind of highlight kind of this question about, like, do you need a high performance home to adopt heat pumps? And my house is 100 years old and I've adopted them, so I clearly think no, you definitely do not. But these are both 2 units, and once again, there's I love all manufacturers equally, and I'm not trying to raise up or pull down Mitsubishi. These are like 2 different pieces of equipment. Both of these are 30,000 BTU pieces of equipment. One of them has a sticker that identifies it being hyperheat. So at 47 degrees, this piece of equipment can put out 30,000 BTUs. And just so you all know, this type of piece of equipment can support like up to 4 indoor units. Okay, this piece of equipment at 47 degrees also puts out 30,000 BTUs. Let's go and look at what happens when we put this equipment in each of these houses. So over here, this you know, historic home needs 100,000 BTUs. neither of these pieces of equipment is going to do much for keeping this house comfortable in the winter time. Let's take a look at this traditional Cape Cod style home. With both of these pieces of equipment, it's not going to do what you need it to do. Just keep it to only go heat pumps over the course of the whole winter. And let's look at this high performance home. This one needs 24,000 BTUs. Even if you put in on this high efficiency home, if you put in this standard type of heat pump that isn't labeled as hyperheat or max performance or XLHT, like if you're just putting in a standard multi-zone mini split that has a capacity drop off, you're still going to need backup heat. So it's not so much like the type of the home, like that will matter, but the big thing is like you need to adopt equipment that doesn't have the capacity drop off. And there's manufacturers that make both type of equipment. And there's people who will say that will talk about the equipment almost interchangeably. But the difference is like two letters in the serial number and the model number. So you do really need to insist that you are trying to adopt these like equipment without a capacity drop off. The thing is, if you already do have heat pumps, this 12,000 BTUs definitely shouldn't be ignored, because that's still capacity that could be used. So let's say in this high performance home, all that you would need would be an additional 1-ton hyperheat type of unit, and now you don't need to have your gas furnace or your gas boiler. As far as this Cape over here goes, that's 50,000 BTUs. One strategy is putting in one of these 30,000 BTU hyperheat units, and then maybe putting in a 20,000 BTU system. And now you have 50,000 BTUs, and now you wouldn't be oversized in this case with, let's say, 3 units on the first floor and 2 units on the top floor. But I don't think that that is like actually the best strategy. I think the best strategy is, why does this home need 50,000 BTUs of heat? Because it probably needed 50,000 BTUs of heat when it was built, but that was 60 or 70 years ago. So questions are, have they weatherized the walls? Are the windows the original glazing? Are, with storms, has the house been air sealed? Is there wide open transitions? Is there a hatch that has fallen off to the knee walls? Has the perimeter of the basement where the foundations meeting the framing, has that been sealed? Is there a door between the basement and the bulkhead? There's like oftentimes with even these homes that are only 70 years old, there's still places of like catastrophic air leaks and just like uncontrolled movement of energy between inside and outside. There's no reason that house, when you're looking at this from a building science perspective, should need 50,000 BTUs worth of energy for a 1,200 square foot Cape. So what's the impact of adopting heat pumps today? These are kind of the only like technical charts that I have, and I just want to highlight over here that this is the equivalent of a home that would need about 600 gallons of home heating oil. I have it using 70 million BTUs over the course of the year. And the numbers that we're looking at right now is just for the energy cost. It's not related to the distribution cost. So the 5 or 10,000 pounds of steel or cast iron to get up to the radiators not included, as well as nor all of the, in Tom's home, the ductwork that was fully connected to the exterior walls, and we know that because it was filled with cellulose after the insulation work. So this is just looking at kind of like how one fuel would compare to a heat pump equivalent 600 gallons of home heating oil. And I have a well-designed and a poorly designed air source heat pump. Now, over here with the teal color, this is going to be the cost over the course of 20 years if fuel prices stayed the exact same. So if you have the world's most efficient natural gas heating system, and you could just buy all of the natural gas today for the next 20 years for it, you would need about 20,000. With a well-designed air source heat pump system, with electricity being let me just confirm, at 22 cents per kilowatt hour, it'd be about 30,000. It's about a third more for just strictly that heat pump or strictly that natural gas. Okay, now there has been plenty of case studies of these poor performing air source heat pumps, and these are really related with the people who have just stuck a unit in a weatherized home and put one in each and every bedroom. So the big thing, and we'll have some messaging on this earlier, is if you are adopting an air source heat pump, just make sure that the equipment load matches the home's heating load. The white bar over here is how many metric tons of CO2 emissions that this heating system is going to be putting out over the course of the year. So if we look at the gas, which is the cleanest of the fossil fuels, it's about 80 metric tons of CO2 equivalents. If we look at the air source heat pump, it's about 50 metric tons of CO2 equivalent. That's if the grid doesn't change. But as we talked about, it's changing. If we look at oil, it's cheaper. If we look at oil compared to air source heat pump, cheaper. If we look at the emissions, they're cut in half. Like those ones are no-brainers. It's just tricky when we are thinking about natural gas. But there's one thing that air source heat pumps have an ability to do that you can't do with natural gas, and that's tie it to renewable energy. So for solar PV, there's been a dramatic, wild fall in price. Kind of when I started doing this is about $8 a watt. 2018 is about $4 a watt. For my own solar system, which I'm going through Tesla, which does not have the world's best customer service, I'm paying $2 a watt for my solar PV. With Energy Sage right now, which is a really good resource for finding kind of like local installers, they're averaging about $3 a watt. So let's just say that you're able to power this heat pump through through on-site renewables. This is what the financials would work. And when I pulled this, this is going to be off of $3 a watt, but this is before all the federal tax credits, state tax credits, smart payments, things around that nature. So with the well-designed air source heat pump, as far as emissions, if you're able to put in a 6 kW system to cover this, to cover the total kilowatt hours that heat pump would need every year, you would need about 5 kW system. You'd need about to invest about $15,000 in solar, okay, for a well-designed system. That $15,000 investment is going to be a lower investment than the $20,000 that you would be paying for natural gas over that same time, over the lifespan of the panels. The emissions would be zero. With solar, just so everyone's aware, with Massachusetts, federal, all the rebates, what you're entitled to, the easy ones is federally, they pick up 26% of the cost of the project. The state, there's $1,000 solar tax credit. And then there's also smart payments that your electric utility would be giving you, which would probably be knocking another $1,000 to $2,000 off of the cost of the system over its life. So it does become this, $15,000 in solar would become, a lot closer to 10. So it's like, at this point, it's like half the cost of natural gas. I know there's different definitions of like net zero energy and, whether being tied to retail net metering really meets that qualification, but I think that this is really an attractive proposition and really is how air source heat pumps win. And this is really why I'm adopting solar for my own home as well. How do I ensure that my system is well designed? Well, I already told you guys my rule of thumb of 20 BTUs per square foot. There's a little bit more nuance to that could be had. So let's say if you live in a high performance home, I'd say you'd probably about 16 BTUs per square foot. And if you lived in a leaky farmhouse, I would say 24 BTUs per square foot. The bigger the house gets, the less BTUs per square foot it needs because there's more floor areas and less wall areas as the house does scale up. This data is what helped inform this decision of me talking about this, but this is all ground source heat pump projects from the Mass Clean Energy Center. So there's over 200 projects. And what's great about this data for me is for ground source heat pumps, you really need to get the manual J heat load calculation right, because it informs all of the boring costs or excavating costs that's tied to it. So when I did come across this data, I'm like thrilled, because it was validating with what I had been talking to people about. But yeah, I think that as you are thinking about your own projects, think about 20 BTUs per square foot, and you can add or subtract a few off of those. But that's what I would have as I'm meeting with installers. And with installers, they're responsible to do an accurate manual J calculation. This is the heat load calculation. This is what you need to be sizing your system on. So if you're not sizing it off of the manual J calculation, you're not going to get it sized right. And you're going to be drifting more towards that poor performing air source heat pump versus a well-designed air source heat pump. The problem with our market right now with the manual J calculation is, to do it right, it requires time. A lot of the HVAC installers don't want to do this unless they have a signed contract for you for the project, because they don't want to spend 2 hours or 4 hours sitting down and doing this right, and then having you take the numbers and then shop it around for a better price. This is the biggest roadblock that I see in the Massachusetts marketplace for getting this done right. Getting these systems done right. But it's something that should be in the tool bag of all of the HVAC installers. They should be designing systems, especially if they do new construction using the software. And with the actual reports, they are easy to spot check. So if you do ask for the report, you can, even if you're not building scientists, you can see, why did they put in single pane windows? I just replaced all of mine with Energy Star windows. Why does it say that my house has twice the square footage that it actually does? So there is some ways that you are able to look through the report and look for abnormalities. And then they also do have like charts and things like that, when it'll be like, windows are accounting for 50% of the heat loss. And it's like, my windows aren't so bad. But yeah, I do think as you are pursuing this, getting an accurate heat load calculation done right, which is called the manual J report, is hugely important. So for my own project, this is what my house looks like. It's in Leominster, Mass. It's 2,800 square feet. The guy who ended up being a sponsor and of Ansel Adams in life, he was born in my house, so the collection at the MFA is named after him. That's our houses claim to fame, the Lane Gallery. But for my own house, this is what it came down to as far as why I did what I did. 2,800 square feet. Before in natural gas, the previous owners, they were spending about $2,300 annually in gas. If I just switched over to heat pumps, I would be spending about $3,000. However, I did a lot of things in my home. I put in 20 Energy Star replacement windows. I did it myself. I paid about $250 per window. And now I have all new windows, except for a few architecturally important ones at the very front. With Mass Save, I had about $16,000 worth of work. With the Mass Save program, the utilities picked up 75% of that. So I did have an out of pocket, but I got all of my knee walls done, my slopes. There wasn't a drop of insulation in my walls, and I also got my basement ceiling. With my ductless job, 6 indoor units, 3 outdoor units, that ductless job was about $21,000 before rebates. After rebates, I'm getting about $10,000 off of it, which is pretty remarkable. So yeah, I think at the end of the day, I'm totally aware I've made a big investment in my home to be saving, let's say, quote unquote, $800 a year. So is it worth it? It's, tough to say exactly, but it's I can't, with the steam heating system behind me, it's loud, it's expensive, it's not particularly comfortable in all rooms of the house. With the mini splits, it's like everything so far has been extremely good. The windows are easy to operate. I don't notice a degree of difference. My house is a lot quieter. It's off of a busy street. And all of these things have been pretty darn affordable because Mass Save program with the heat loan and being able to kind of finance it. So it's like, I'm saving money, I'm reducing my carbon footprint. With all the work, I dropped my heat load from about 90,000 BTUs to about 45,000 BTUs. If I hadn't made all of these improvements, I do think my ductless job, if I wanted to have the same amount of capacity, it would have been about $36,000 for like doing this home right. But because I did invest in the windows and I did do the Mass Save work, I do think that it ended up being able for me to size the ductless job down. And oh, go ahead, Tom.
Okay. We had a question from Julie Carney that I think fits in pretty well here.
Okay.
Does Mass Save pay for the consulting for design of the system? You know, because if the HV contractors are incentivized to oversell, you know, how does the, you know, average homeowner figure that out? And given what you've been talking about, it seems like the design of the system is so crucial and has to be right. And, you know, can we just leave it to, you know, the HVAC installers themselves? I mean, that manual J calculation sounds like it needs to be done by somebody quite knowledgeable or expert, and you think?
Yeah, that's so I will say that with Mass Save now, they are on they're drafting their next 3-year plan, and there's going to be a lot more talk about electrification and decarbonization and air source heat pumps being part of it. It's hard for me to say whether or not that they are going to make every energy audit also have a generate a report specifically for this one technology. I have where do we begin, and I'm just going to hop forward a slide and then I'll hop back one slide, because I do think that this is going to be all resources in finding someone to do this. So I would just start with this. On the Mass CEC's website, which is the Clean Energy Center, because it's partially government funded, all of their records are public. So all of the programs that they've run in the past for air source heat pumps, you can find out where the installer, what town it was in, how much it cost, and like what the manual J calculation was. So I like this because that's one resource on the Mass CEC's website that you could have to not find all contractors who understand the technology that runs this report. I think the other thing that's hugely important too is like social media word of mouth is just ask around. I'm sure that there's probably a Chelmsford next door page or Facebook page. Be like, hey, I'm looking for I want to do mini splits, looking for a contractor who does manual J and installs heat pumps. And I'm sure that you will get some people who are looking for business that is referring, that's referring. So I just think that like, as long as you start this process with kind of saying that, like, I'm interested in getting a manual J calculation. Where does this happen in your sales process? I understand you don't want to do this for free. If we lightly design a system and you then do it, will you revise the equipment? So especially with like sole proprietors and independent operators, I think that they're like a lot more flexible. But the larger companies that do have, let's say, like comfort advisors, and then they have install technicians and service technicians and people in the office, like, I don't think that it's hard for me to see that like getting these systems designed perfectly right. I just think that it's hard for those companies to kind of do it at the scale that their business is built in, because at the end of the day, a lot of their calls and a lot of their customers are just people who are the complexities of central AC because of the architecture of their home. like that's still where a lot of people are adopting these systems. They hate their window ACs. Central AC is not feasible. I want ductless. And that's what a lot of the contractors are still doing. So I will say for my, and it's like, I don't know about, I said the name Energy Sage earlier, and I don't know if there's any like conflict of interest with naming contractors, but for my own mini split contractor, he's based in Chelmsford. A company's My Dear Watson. And I think he was great. I did my own manual J calculation, but it's he would have been able to do it as well. But yeah, I think just asking, I think word of mouth is really good. Finding someone local, I think, is really good as well.
What was his name again, Mike?
The company's My Dear Watson.
Oh, okay.
We talked about this before, but anytime that you're doing the mini splits, just make sure to first fully weatherize your home. I didn't do a deep energy retrofit. I just did kind of what you're supposed to do, with like insulate your walls, replace your windows, insulate your attic, and I brought my heat load down by half, and I made it a lot more affordable to, you know, I have all faith going into this winter that my mini split system is going to be a lot more affordable to run than my gas steam system ever was. And that's only true. And I only win those like cost competitiveness having first weatherized the house.
We've got a couple more questions, Mike.
Okay.
Jesse asks, what is the relationship between ductless and air source heat pumps? Seems there are ducts, except when you have when you have a through the wall unit. I guess I'm not quite clear what they're asking.
Yeah. So ductless. Okay, this is a little bit tricky, but all right. So in say southeastern Massachusetts, southeastern United States, so like all of like Georgia, Mississippi, Florida, the Carolinas, they have had heat pumps for years. For like the last 20 or 30 years, heat pumps were the main way that they were cooling their home as well as heating it. And it would work perfectly good because their heating load was relatively very small. So all of the American manufacturers, the Trane, American Standard, Carriers, Lennoxes of the world, they all sell heat pumps. Okay, and that's what one product category is. Now, the Asian manufacturers, the Fujitsus, Mitsubishis, Daikins, they've had their own type of heat pump, and their type of a heat pump has been called a ductless mini split. And that was traditionally the one unit outside and the one unit inside that would be on the wall. However, both of those industries, both like the East and the West, they've been like merging in some ways. So the Asian manufacturers now make ducted equipment that's typically much smaller in size than the big kind of American plenums and ductwork. And the American manufacturers now also have ductless equipment that can be tied to still kind of their like bigger, chunkier outdoor units. So ducted mini splits is, when I am saying that, I'm typically referring to the Asian manufacturer's piece of equipment that's tied to the same outdoor equipment that the wall hung would be, but instead of relying on a, you know, indoor unit that's on the wall, it's relying on ductwork to distribute it to 1 or 2 or 3 rooms.
And well, I don't know. Do you want to just start going through all of the questions that we have in the chat?
No, this is, I got through everything that I wanted to. So let me share the screen.
Well, great. So either I'll read them off or I'll just have the person ask. But okay, Kathy asks, what is the lifespan for the compressor outside and the indoor unit?
Yeah, with most manufacturers, their warranty is between 10 to 12 years. So if they're warrantying it from 10 to 12, I think that 15 to 20 is what you should expect. I think that it is important as you are flirting with the idea of doing this is know that most HVAC, high efficiency HVAC equipment, whether it's gas or oil, is not going to last 100 years or 50 years or 30 years anymore. The ages of steel and cast iron heat exchangers, that has disappeared, and now that they're extremely a lot more efficient, but they're also extremely less robust. So if you are talking about getting a new wall hung or combi boiler and you ask me the exact same question, I would also say probably 15 or 20 years. So that's not,
Okay.
you're not getting more robust equipment by sticking with fossil fuels. You're getting, you're getting kind of the same thing one way or the other.
Okay. Okay, next question's from Dave Drayton. If I wanted to identify the biggest holes in my home's heat load efficiency, would it be a matter of hiring someone to do a manual J evaluation, or would I need someone to do a different kind of energy efficiency evaluation?
Yeah, you would want to get a energy auditor who would have access to a blower door test. And that's how you actually find the largest holes of the home. So a blower door test would be most helpful in that. And with Mass Save, I would always just start with there because the energy audits are free and the weatherization work is 75% off. And usually most of the large holes in the home get addressed in that work scope. So I would just first start with Mass Save, see how far down, see how far along that street gets you. And if you still feel as if your home has large holes in it that need further investigation, then I would be trying to likely contact like a HERS rater, like a new professional energy rater who would be able to do a blower door test with infrared, and they could really kind of hone in on what the problem is.
Okay, great, Mike. I'm going to let Arnie ask this question himself. Is that all right, Arnie?
Yeah, thank you, Tom.
Okay.
Mike, terrific presentation. And I'm actually a member of a group called the Heat Smart Alliance, and I know that you're working, or Abode is working with the Concord Light plant. So that's great. I actually live in Stowe, but we did our what's called the Heat Smart program, which I'm sure you're familiar with, about a year and a half ago. And what I ended up doing, and what a lot of people in Stowe did, is I have an existing ductwork in the house that's used for heating and cooling, fuel oil heating system, and replaced the whole house air conditioner with a Bosch heat pump. And what the installer told me was that the real issue in moving entirely off of fuel oil in my house, which sounds like it has a heat load similar to the one that yours did. And we don't get Mass Save here. We're a municipal light plant, so we don't get the rebates that you get for weatherization. The real problem, he said, was that because the temperature from a heat pump is about 60 degrees lower than that coming off of a furnace, that the existing ductwork would not be able to carry the amount of heat that would be necessary to heat the whole house. And if I were to try to move off of fossil fuels entirely, that was a big deal. I mean, it meant either, upsizing my existing ductwork or doing an amount of weatherization that, he couldn't give me a number. I did have a blower door test done on my house and had someone come in, and they couldn't guarantee me how much they could actually improve the air sealing of the house. So we ended up with this dual fuel system. I just finished my first full heating season, and I have an intelligent thermostat. It switches between the heat pump and the fuel oil furnace when it finds that the heat pump can't keep up. And I found I displaced, almost 90% of my fuel oil use. I can, it gets down to 22, 23 degrees before it switches over to the fuel oil. So I guess my question, and the people I've spoken to said, well, if you wanted to, get rid of fossil fuels entirely, that's a, that would be a big uptick in terms of your costs, either, an amount of weatherization, which they couldn't exactly say how much that would be, or, maybe putting a couple of ductless mini splits in the house, but then I wouldn't have this automatic switch over. Hopefully I wouldn't need it. But I was sort of thinking about that and what we need to do in the state as a whole in terms of retrofitting, what we think are, 1 million homes in the next 9 or 10 years. And whether, can we realistically think of those as being, weatherized and have a heat distribution system capable of making these homes all electric? Or should we think about these sort of dual fuel systems, which are capable of displacing 85, 90% of the existing fossil fuel use and have that be one pathway as well?
Right.
So I know I've gone on a bit, so.
I did too, so you're welcome.
I should have just read your question.
Sorry.
No, you brought up a lot of really good points, and I did forget to kind of go back and just talk about the submittals and look at kind of how the heat pump really does perform on lower temperatures, and it's right now nothing to write home about. So you put in, typically on the lower temperatures, you're putting in 1 unit of electricity and you're only going to be getting out 2 units of heat versus, close to 3 or on 40 degrees like 4. So the performance really does drop down, and it does get, as that happens, it does get a lot more expensive to operate. Now, based off of what you said, where you're not switching over till 22 or 23 degrees, and you're cutting your fuel costs about by your home heating oil consumption by about 90%, it's really fair to say that there's not too many times that we actually do fall below those temperatures. The average winter temperature in our region is about 34 degrees.
Right.
It's only usually 15 days that is below, over the course of the year, that's below 17 degrees, and there's only a handful of hours that happens. So there's nothing wrong with that. If I was presenting to contractors, I'd be talking a lot about unitary systems. So that's swapping up the gas furnace and putting in a gas heat pump, but there's just so many considerations, which you touched on, about whether or not this is a good thing to get consumers, I think, excited about. And maybe I should have included some, but it is really hard to be recommending adopting, putting in a state-of-the-art heating system typically in our region, a distribution system that was 70 years old and never designed for this, and never properly sealed, and and you can't ever, there's products on the market like AeroSeal and things like that, but just even anytime with a 2-story home, you can't insulate those ducts without ripping open walls, and now you got condensation, and it's just I think a lot of the comfort, I think a lot of the promises of get really mucked up when talking about it. But I do think that if you do have a reliable HVAC installer who can walk you through all the pros and cons of doing it, there's certainly nothing wrong with doing it. I just think that it does require a lot more consideration versus ductless, where it's like, even though I'm quote unquote a building scientist on a good day, I didn't need to like measure any pressures or do any diagnostic tests before making the decision to do this for my home. It's like, I got the calculation and then I put them where I want. But if I am going ducted, then it is like, how am I making sure that the airflow is right? What's going on with all of the condensation? Are the ductworks big enough? Do I need to change the register? Should this be going through the basement cell? It's just like, it's an in-depth conversation that's totally worth exploring, but time is limited.
Okay.
So I think it's about half of the homes in the state are use forced hot air is my, I don't know where you get your data, but it's a substantial number of homes, and many of the homeowners there, want to keep their existing distribution system. So, and a lot of people don't like the look of the refrigerant pipes going up, the outside of the house, or they don't like the look of the heads in the walls. So keeping your existing forced hot air is they see as a benefit.
Yeah.
But it does present the issues, I think, that you spoke to and I ran into.
Yeah, and with that remaining 10% of your home heating oil, the 10% of the home heating oil, and then the previous discussion related to redundancy and things like that, those are really the cases where particularly with the Bosch system, I see a lot of the Bosch systems going in. It's the heat pump, and then there's like a 10K or 14 kW electric coil on the inside. And then that does mitigate my fear of like getting out and shoveling after 2.5 feet of snowfall overnight, because it's like that 10% difference, you can bring down that with envelope improvements as well. But yeah, there's nothing wrong with just running a little bit of electric resistance for those coldest of cold days, or while you're actually shoveling out the outdoor unit. And shoveling out the outdoor unit also happens with high efficiency heating systems too, just so everyone knows. With the new high efficiency systems, they're all vented out the sidewall. They're not going back up and out the chimney. And those also need to get shoveled out, because if it can't push the exhaust gases out, the systems are smart enough to not have the systems fire and fill the house with carbon monoxide or melt the PVC plastic vent pipe. So yeah, they're shoveling, I guess, either way. We live in New England. I guess it's what we do. Yeah.
Okay, couple more questions or a request. Julie would like to see that slide. We had Energy Sage.
Yeah.
Explain a little bit more about what they do. Energy Sage does.
Oh yeah. So I sent over the PDF earlier. Hold on. With energy, I sent over the PDF, and you're welcome to send it out. But with Energy Sage, there's no wrong way to go solar. You can call Sunrun or Vivint or Trinity, and all of those companies will help you sell solar. Sunrun is kind of cool because Energy Sage is kind of cool because they do work with, I believe, those larger companies, but they also do work with local installers, where they kind of go and they say, hey, you're interested in solar. This is the project. This is the roof. This is, roughly how much space is available. This is the, sun angle and all of that stuff. And then local installers can all propose quotes for you to review. They pay Energy Sage. You don't pay them anything. And then you can kind of go and be like, all right, I want to meet with that person, that person, and that person. And it's kind of a good way to shop for solar. But yeah, it's more like the local installers is participating in that versus kind of more of the larger ones with like the Vivint and Sunrun, Trinity, and all of those. So it's just one way to go solar. With my own project, I went with Tesla. It's been horrible customer service, but they're selling solar at $2 a watt, and I've spent a lot of money on other energy-related projects this year, so I'm going for the lowest watt I can find.
Okay. I'm trying to unmute Dave so he could ask his question. But yes, Dave, do you want to ask the question about brands?
Sure. So I'm just curious, you mentioned earlier that you call heat pump brands equally. But I'm wondering if any of them stand out to you, either because they have extra good features, or maybe they're just well positioned because of some other reason that you would want to recommend them.
Yeah. So the reason that I would go with Mitsubishi is just they have so much percentage of the Massachusetts market share. Like it's like 70% of the installs right now is happening with Mitsubishi equipment. And it's not because it is like the very best performing piece of equipment. They just have, you know, the right contacts with the right distributors and the right training. And it's like more of that stuff's going in. And I think what's really good about that, I think it's the same thing of like, you know, that if you bought like a Volkswagen Beetle like 40 or 50 years ago, you can like still find parts for it. You know, like there's still like, there's just like, I think that just the scale of what they're doing, I think it's going to ensure that there's going to be a lot of parts for servicing, and there's going to be a lot of people who understand specific nuances of the equipment. With my own project, I ended up going with Fujitsu. And I went with Fujitsu because the range of the multi-zone equipment with how long it's modulating is significantly better than Mitsubishi. So I got there's a unit right here in my office. This guy is tied to it's quite large. It's a 36,000 BTU outdoor unit, so a 3-ton unit. My system, which it picks up the office, the hallway upstairs, as well as the foyer downstairs, it ramps all the way down to 1 ton. So between all of these kind of spaces, I just need to find 1 ton of heating or 1 ton of cooling, and that system is going to be able to operate at its peak efficiency. If I went with Mitsubishi, it would be about 1.5 tons. So it does lose a bit of its like ability to modulate. So I think that's kind of the big reason. Also with the difference between Mitsubishi and Fujitsu, you can find the Fujitsu equipment, maybe you'll save $1,000 or $2,000 on the larger jobs. The manufacturer that I'd like to see that's bigger in other parts of the states, that hopefully will regain, that's putting in Massachusetts is Dakin. I guess going to Arnie's point earlier, they're kind of the only heat pump manufacturer that it's like they have a fossil fuel based base with a heat pump with no capacity drop off that sits on top of it. So that's really exciting because all of the like other, I guess like American brands, they have the heat pump, you know, they have the fossil fuel base with the heat pump that does have the capacity drop off. So yeah, and Bosch, they have a Ductless lineup that's coming out shortly. They're a European manufacturer and their equipment looks really, really great. So I don't know, I think they're all good. Just know that if you do go with an American manufacturer, you do have the capacity drop off. There's nothing wrong with that, but you do need to just kind of take that into account. But all of the Asian ones, it's all kind of the, you know, they're all very similar as far as performance goes.
Okay, thanks. And just a quick follow-up to the previous question I asked about the evaluation. So you said I needed to get a blower door test. And I saw that you had a slide that was about efficiency companies. Would those be the kind of companies who would do that test?
Yeah, so those would all be massive contractors, home performance contractors. And anytime that you have an audit and they find an ability to air seal the house, part of what Massave pays the contractors to do for air sealing is run a blower door test. And they're not necessarily running it as a diagnostic tool. They're just kind of making sure that they don't, quote unquote, over tighten the house. But But if you do express to like those companies that if there was air sealing, you'd just be interested in like having the blower door run while like poking around, that's something that they would be able to accommodate. But yeah, otherwise, like getting like a thermo, like getting a HERS radar with a blower door and an IR camera, they would be charged like 500 or 600 or 700 bucks to do that type of a visit. So I do think trying to piggyback it on top of Mass Save is definitely the right way to go. But yeah, and then I guess the other thing with like, if a home, like if you know where a home's leaking, like I would just try and seal it, especially in the days of like YouTube and, you know, it's all, most ways that homes can leak is like you can, there's so much do it yourself stuff. And yeah, there's definitely ways to kind of screw up a home, but like if there's a hole, seal it. Unless it's next to a combustible thing, then that's a different story.
Okay, is there a particular time of year that I should get that done? Like, is it easier to find leaks in the winter, for example?
The IR camera certainly looks way cooler the bigger the temperature difference is between inside and outside. But they're able to, the blower door number doesn't change. And especially in the summer too, when you run a blower door, all the like super hot humid air just gets pulled straight down from the attic. So you get really good looks this time of year too. So it's really just the spring and the fall, like the perfect day. When it's perfect outside, it's not a perfect time to get the most use out of an IR camera. And then the other things, I don't know on the scale of like 1 to super nerdy you are, but Flare, they now have ones that plug into like USB ports on cell phones or into the iPhone port for like $250. And the quality of these things is mind blowing to where a $5,000 IR camera was 10 years ago. Like it's come a real long way. So, you know, there's nothing wrong with like buying one on Amazon and selling it on eBay after you've, you know, like tried to figure out how your house works. Because
or maybe the library should have that in its I forget the name of their program where they
Like a tool rental program?
the tool, yeah, that'd be great. Oh, we've got a question from our illustrious Kathy Kyan Hicks. Can you speak about actually using the mini splits most efficiently? Like, I mean, today she turned them off and opened the windows, and
Well, it's just, you know, sometimes I feel like I'm doing it by comfort.
Yeah.
I'll be in a room and I'll turn the fans down because it's too cold, or turn the temperature up or down. And in the winter especially, it gets a little confusing because we've got oil heat still, and that's in the background. And you know, I'm always going by how I feel. But when I go to bed at night, then it's like, what do I do? You know, I'm not going to feel it. So, and I don't want to waste electricity, but I don't want the boiler to turn on the, you know, and use the oil. And so is there some kind of a rule that I can just, you know, just tell me like, it doesn't use that much electricity, so I should just leave it running all the time? I don't know. Is that?
Yeah, all of the different program evaluators in the Northeast have all agreed that you should, and especially in the wintertime, you should think of it as the same way as your refrigerator. Just plug it in and just leave it be and just figure out what's comfortable and don't mess with it, because they run they run their, like, just like your car can go like 150 miles an hour, you know, it's not happy doing it. And mini splits aren't very happy with picking up a massive heat load. They would rather just kind of like ramp up and get things where it wants to be, and then work a little bit harder, a little bit softer, and just have it run. So I think that the messaging is just figure out what's comfortable for the whole home and just try and set it and forget it. For the summertime, I think that like it's a lot, we were talking about this before the call started, it's a lot harder to say like how to run this perfectly. But if you're having like, so for my own home, and I'm very new to this, mine just went in this past week, but it's like I'm shut in my office right now. I got my unit on at 74 degrees. It's quite nice in here, but my door is closed. I understand that like my thermal envelopes, my exterior walls and not my interior walls, but on the other side of the door, all my mini splits are off, and all of my windows, my new windows, are open.
Open.
And that's just the strategy. And like, I would have my window open too, but I'm like on a busy road, and it is like, you know, there's
Yeah.
fire trucks. So it's like, it is, these are like the benefits that like, you know, you just like, it's hard to quantify if like, why, you know, why did I do this? But it is
Yeah.
kind of nice to have the flexibility that everything's not needing to be on or off. And if you do want to zone, you do have the ability to zone. But when you are thinking about not running your fossil fuel system, I think the right choice is figure out what's comfortable and don't worry about the temperature that it says. Like if 74, it says 74. It's like, I never had my original thermostat at 74. Like, don't worry what that says. Just figure out what's comfortable, let the heat pumps do as much work as possible. And that's what all of the evaluators say to like kind of get these things towards well-performing versus poor performing, or well-designed versus poorly designed.
Okay. Yeah, we originally put them in because we had window air conditioners that we'd have to lug up and down the stairs every season. And, you know, the more I learned about heat pumps, I said, there's a solution. So it works great in the summer for cooling everything. And then I decided, and there'll be a backup, but we've kind of switched it around. And I did figure out how much the cost difference was with the oil and the mini splits. Now we're not paying any more than we did before. Plus we have air conditioning and we have our windows back, and we don't have to lug these things up and down the stairs. So that alone has been worth it.
Right. And with home heating oil, like I know that it's like, you know, the home heating oil prices have gone up and down no matter who is president. But I think it's fair to say, like, it just really does feel like, are we going to see, you know, is home heating oil, because right now it's at like $3 and it's been heading up toward $3, but I'm sure you've lived in your house long enough where you spend $4.50 a gallon for it. But like, you know, it's just hard for me to imagine that like home heating oil is ever going to get, like, it just can't be as cheap as it is today. So I think that's one of the things that with the adopting these that I did feel good about this is I'm sure that natural gas is not going to be able to be as cheap as it is today, just because it's not regulated the way that it should be. And I know that, you know, it needs to change. So.
Thank you. This is great.
I've got a question, Mike. You mentioned a few times that you just got new windows. So I'm curious if you could speak to which type of window, what to look for in windows in order to maximize home efficiency. And I'm also curious how the heck you got 20 windows for $5K. Like that's nuts.
Yeah, well, I did. I installed them myself, but there's a building supply. And so as far as strategies go, one, I think, and once again, with the age of YouTube and things around that nature, it's my finished carpentry skills are not good. So let me just say that, like, if I needed like actual carpentry skills, I would have not tackled this project. But there's plenty of like general, and things are crazy right now, I understand, but there typically is general contractors that if you go buy your own window and you say, hey, if I go, you know, will you measure the windows for me? I'll go buy them, and you put them in for $100 or $200 per window. And I think the difference between those two factors is whether or not they're going to, you know, how much caulking, how much painting, whether they're going to wrap the, you know, the exterior trim with aluminum. Like, there's a lot of factors that can go into it. So yeah, so with as far as the replacement window goes, there's double pane and there's triple pane. If you're not planning on like, if I thought in the next like 10 years, my house was going to be verging on high performance, I would be going with a triple pane window, but it's like, I'm just trying to get a good enough house, like I'm just trying to like prevent catastrophic air leaks, not waste money, do everything that seems like low hanging fruit and practical. So with Windows, they get a U factor rating, which is its performance. And if you ever want to make sense out of U factor, you take 1 and you divide it by that, and then that would give you the R value. And people know R values from insulation because like an inch of fiberglass is like an R3. But so the difference between the two is that's like a lot of information. But like a double pane Energy Star window, it's like an R3.3. It's like has as much insulation as an inch of insulation. But it's kind of cool because when you actually do look at the sash of a window, they're only an inch thick. So it is kind of cool that like an inch of see-through glass has as much insulation as an inch of insulation. But a triple pane window, sorry, that's very silly. A triple pane window would be like an R5. So it's not quite double the amount of resistance. But yeah, if you did have like, say, closed cell spray foam in your walls, that was like an R19, it'd be a shame to like pair that R19 wall with like an R3 window. You'd want to kind of get like the best performing window to kind of match with your best performing wall assembly, because at that point it's like, wow, now my walls aren't like losing hardly any energy. So it's like with my walls, with retrofitting cellulose, with all the additional blocking of like an old home, it's like it's like and it's good enough, I think, is what I'm trying to say. But right, they have like a silly jingle, but right window there, I know that they do replacement vinyl windows for like starting around 500, or at least they were a few years ago. But then like once you do want to get the trim wrapped, and once you do want to get, triple pane, then, things start migrating up to 1,000. But that's kind of a company that does it on a larger statewide scale. But I think just trying to, reach out on Nextdoor, Chelmsford Facebook group, just trying to find like a general contractor handyman who'll just come out, measure it,
Okay.
and then work with the local building supply shop, and not like the Harvey Marvins, Andersons of the world.
Oh, interesting. Not the Andersons of the world. Just overpriced.
Oh my goodness. Yeah. No, the renewal by Anderson, they'll charge as much for like a single double hung as my whole window project. Yeah.
Okay. Yeah, I know when they came, everyone who I've gotten quotes from, they took this little like heat gun or something, and they would show me how the heat would go right through my windows. Do you know if that's just a gimmick? Because everyone's done that. And I want to know if it matters.
Yeah, so if you were to go and do that same test with the $250 replacement windows that I purchased, it would have pretty much the same identical result. So with replacement windows, they have a low E coating, low emissivity, and it's like aluminum foil, but invisible. So instead of the energy, hitting through the glass and then emitting through it, it just makes it, ricochet back. And it's like cool, and it works. And triple pane does have the advantage because it really does separate inside from letting the heat inside from radiating out, and on the outside, letting the outside from radiating in. And on a double pane window, you're either, depending on which way they're putting the low E coating, you're kind of letting the outside air, outside radiant energy get into kind of the window pocket and then warm it up. And then it can cause, quote unquote, more discomfort. So yeah, triple pane are like better than double pane, but you shouldn't need to spend $2,000 on a good quality replacement window.
Okay. Anderson was like, we're the only ones with this special gas between the windows. Is that?
Yeah. And there's like argon, krypton, and then there's like other ones. But yeah, the sad thing is, it's like, I know that they're not going to last forever, unlike the wood windows that I pulled out of here, which lasted 100 years. So, Yeah, it's tricky. It's like we need to do something differently. I don't think we've solved all the answers when it comes to glazing. But yeah, I don't mind a company like trying to make innovations in the marketplace and like keep people employed. But yeah, I also don't think window projects need to make people broke. So
Gotcha.
Well,
Thank you very much.
you're welcome.
well, I think we're starting to run out of time. Is there anybody that hasn't spoken up at all that would like to ask one last question? But, oh, no, not you. All right, okay.
Who's that?
I'm gonna just listen and I just need to send a super quick email just to let my 3 o'clock know that I'm just gonna be running a minute late. Sorry, just 1 second. Okay. Oops, sorry, hold on. Okay, I am back with you.
Okay, last question.
Okay.
Okay, thank you, Mike. So this is a little bit off topic, but not totally. So I said, we live in Stowe. We're served by a municipal light plant. Our electric rates are literally half of what Chelmsford's are.
Yeah.
And we have 2 and possibly 3 fairly large developments coming into town in the next 2 years to 3 years, one starting probably later this year. And we are a green community, so we do use the existing stretch construction code. We're trying to figure out how to encourage the developer to make these new homes all electric. And the question, from a operating cost perspective, it's pretty much of a no-brainer in Stowe, even compared to natural gas. The question that we've been struggling with is should we really be encouraging the developer to build a more energy efficient, tighter home than required by current code, in addition to making the home all electric? And then they start really saying, oh, additional cost.
Yeah.
Or should we focus more on, well, just build to existing code and, install the heat pumps? I know this is sort of off the wall, but we've been struggling with how to work this issue. And I don't know if you have any thoughts on that.
Yeah, no, it's good. I think that the big thing, I think once a developer knows, so running fossil fuels, so I don't know if there's any possibility of natural gas being brought into the project, but just even venting gas systems and like bringing the fuel lines over and just eliminating all that. It's so much for them to be building all electric, especially when the equipment cost is comparable. And as you experience with your own Bosch system, that it's the exact same as, air handler central AC. And then it's just the difference is just going to be the electric resistance coil. So I think with the mechanical, it's like a 1-for-1 swap with when you are thinking about forced air. And then it's like, it's like, I know that with new construction it can be a whole lot tighter, but I think even with the stretch code towns, but yeah, I'd say that the benefits, it's like, I would say go and push them as far as you can with getting the building tight. But the big thing is keeping all of the distribution inside of the thermal envelope. So like no ductwork running through like unconditioned basements or slopes, because that just like throws everything off. But yeah, it seems like the benefits of just this all electric. And I know that there'll always be pushback with people wanting to like cook on gas, but hopefully now with what people have learned about, particulates and personal CO2 monitors and things around that nature, they'll be more apt for the house of the future with any new development really looking like all electric.
So that's what we're trying to tell them, but I don't know. Yeah. And, I think a couple of years from now with the new the new code, the new construction codes, and probably some new regulations, it won't be as much of a push. But, we just happen to be caught.
Yeah,
in this.
yeah, because people grew, it's like people grew up on it, they were marketed, so yeah, it's tricky. But I think the big thing is for any developer is just knowing that your town building inspector, the mechanical inspector, the plumbing inspector, that they understand that heat pumps capacity can replace fossil fuel system if it doesn't have the capacity drop off. I think the worry for a lot of builders right now is thinking that they're going to be putting in heat pumps, and the building inspector is going to say, oh, that's not going to work. You also need to be, putting in this or putting in that. So making sure that that's addressed would be huge, and just giving the builder confidence that they don't need to worry about the fuel lines. They don't need to worry about the venting. They can just kind of put the system wherever they want it, and it's all electric, and there's nothing to worry about there.
We hope so. I'm gonna just ask Mike one more question in the same area, because this is.
But I wanted to follow up on your question.
Okay. Do you
And then
know of
can
any?
ask your follow-on, Paul.
Do you know of any, developers who are building more or less to the existing stretch code and are building all electric? Someone we could point these developers to and say,
Yeah,
talk to.
I would point you to a particular HERS rater that's also a heat pump installer. I would write down his name, and he's really familiar with what's going on in the state for builders. The company's name is Ace Energy, and the owner's name is Tim Gould.
Okay.
And before this meeting, I was in a training class for becoming a HERS rater, and I will be completely honest, I don't know much about the builders and remodelers and who's doing what and what all of the actual obstacles are with new construction, but retrofits, I feel very good to talk about. But I think Tim Gould would be a really good resource, with trying to get a better idea of this. And because he was just going out doing HERS raters for new construction, and then he just pivoted to also offering heat pumps because he just thought it was so goofy, all of the, what everyone was doing to kind of maintain these legacy types of systems and distribution. So
Thank you, Mike. And I apologize, Tom, for
Okay, so if you're building a house brand new and designed for electric, for heat pumps, it sounded like you were envisioning they go with ducted. Why not just have design and have mini splits?
Yeah, so I think that it's likely a combination of ductless and ducted will likely be the solution. Mini splits are typically most popular because they're very easy to retrofit. I think if you were dealing with new construction, I think that there's a very good chance that'd be all ducted, or it could be a combination of ductless and ducted with some of the smaller, slim duct or medium static units where you're just hitting 1 or 2 bedrooms. But it's a mini split does not add any interior design interest, it's adding a piece of mechanical equipment on the wall.
Yeah.
So if you can add a register on the floor, it's well, that's probably a better solution if it can be just as efficient. So yeah, there's nothing wrong with ductless. Yeah, I would just say new construction is likely ducted.
Okay. Boy, you tired us out. That was terrific. Thank you. Thank you so
Wonderful.
much.
Thank you.
This is great.
Great.
And
Perfect. Well,
best of luck.
Well, yeah, best of luck to all of you, and thank you for having me. And I'll make sure that I subscribe to the newsletter. And yeah, but feel free, shoot me an email if you are pursuing this, and happy to point you in the right direction. Okay.
And if anybody wants the slides, I can forward those to you. Let me know.
Great.
All right. So See you next time. Keep in touch.
All right. Thank you, Mike. This is
Thank you.
wonderful. Thanks,
Bye.
everyone.
Thanks, Mike.
All right,
Okay.
bye.
Bye-bye.